Okay, so I am going to talk about nuclear bomb, what is happening inside it. So first of all, the prompt said talk about nuclear fusion. However, the video discussed nuclear fission, and I'll touch upon the differences there. So I'm going to focus on nuclear fission. Um, because so in nuclear fission is the process of an atom splitting into two more pieces, which releases tremendous amount of energy used in um, powers nuclear submarines, nuclear bombs, etc. And that is what the video talks about is the nuclear bomb that was used. Fusion is when two or more entities come together. So, in the case of nuclear fusion, combination of nuclei, so lighter nuclei coming together with a heavier nuclei, but that was not what was discussed in the video again. So, anyways, I'll focus on nuclear fission. Um, so nuclear fission, it starts with an unstable atom that it needs to be unstable so that it can be split, because what will happen in nuclear fission is that atom will be split into two smaller atoms by nucleus and or a neutron, sorry, not a nucleus, a neutron, which will then, so that neutron splits the atom into two more, but during that, more, uh, in addition to the two new atoms being created, there's also an addition of neutrons that are created during that when the um, when the two smaller atoms are created, there's also an addition of neutrons that are created. So then those neutrons can then collide into the two new atoms, the two smaller atoms, um, and then then those new atoms then split, and it's just kind of in this is what is called a chain reaction. Is that one, it starts with one atom and then more and more atoms created are splitting, and each time more energy is being released, and so the accumulation of all of that energy um, is what uh, creates the effect of the bomb and all of the energy. So um, basically you need a, a pretty big amount of atoms in order for that chain reaction to start. So in the case of the Hiroshima bomb, uranium was used, and uranium has two main isotopes. Isotopes are atoms that are have the same chemical um, chemical characteristics. They don't differ at all. So they won't have different boiling points. They won't have different magnetic um, they won't have different levels of magnetism and things like that. The only difference is that one weighs slightly less, and that would be uranium-238. So the two isotopes are uranium-235, uranium-238. And the only difference is that uranium-238 weighs slightly less. So that makes it just a little bit more unstable, and that's why that isotope is used in the bomb. And so the video talked about, which was really interesting, is because that's the only difference, scientists had to come up with a way to separate it. They couldn't, chemically um, pull it out. They couldn't, use a magnet and all of the and one isotope separate from each other. So they had to, there's two ways that the video talked about is that running both of the isotopes through miles of tubing and creating different ways to separate it based on the weight so that the uranium-238 will be released one way and the uranium-235 will be released another way. So they had warehouses of just tubing. And then the other thing that can be done is running the isotopes through numerous centrifuges. So it's a process, and there is is like a wheel that turns inside of it, and it has to run through multiples of those to over time get enough uranium-238. Um, and it touched upon that those centrifuges have to be engineered very, very precisely, or that wheel will eventually and pretty quickly start to fall apart, which they said wasn't necessarily a bad thing, because then we don't have a bunch of centrifuges used to create nuclear energy all over the place. So a couple things that are necessary is that uranium-238 needs to be the one that is split, and then you also have to find a way to separate the uranium-238 and uranium-235, because the only thing that is different between them is their mass is slightly different.